In this project, we're going to use a photoresistor, which is this device, and we'll read its value by comparing it to a resistor with voltage across, +5 to ground. As the photoresistor changes its value compared to the resistor here, due to light changing, it'll change the value of the electricity or the voltage that is available to pin 9. A program will sense that, and based on that value, change the position of our servo. Enough of this, let's begin. Let's begin by connecting our photoresistor. I'll put it in 2 pins into 2 different rows. Those 2 rows we refer to as nodes. There we are. And according to the schematic that I had, one of those nodes needs to go to +5. I don't know if you've noticed, but I've routed my plus and ground to these 2 strips, the blue and the red, so they're not in the way when I build projects. So I'll connect this red wire to the plus side, which is any of these pins along the red line. You'll recall that everything in this line that runs beside the red from one end to the other of the board is all the same wire. Everything that's in the other line along the blue is also on the same wire, and for us it's ground. Well, I have my photoresistor connected to plus, so I'll connect another resistor, and this resistor is a 10K. That means its colors are 10, which is brown black, that's 1 and a 0, and K, which stands for 1000, which stands for 30, and this 3 zeros, and in this case orange means 3 zeros. That makes 10K. Okay. The only thing that's left to hook up for the photoresistor is a signal wire. We'll connect that to this middle node where the 2 components come together, and we'll plug that into A0 over here on this side. Okay. So with that done, let's hook up our servo. Now our servo often comes with a connector that would plug right into a radio control or a robot device. And I've chosen 3 wires to plug in to help make that connection. Red, black, yellow. And it turns out that the signal wire is the yellow, the middle wire is red, which is a +volt or +5, and the black would go to brown. And that's how I would connect my power. So I will connect these 2 up now. The black to ground, that's that bus. The red to +5, and now this yellow wire needs to go to pin 9. And now we're ready to download our code. The code I'm going to load can be found in examples and in our standard set of examples under servo at the bottom under knob. Now this code is written to be used with a variable resistor, one where you would turn the knob to change the resistance. But we're going to do something a little more clever. We're going to actually put in our own variable resistance triggered by light. In this program, it looks like our code, our sketch, includes another block of code called servo.h. And some of these functions will be found in servo.h. So I suppose servo, my servo, is a way to create an object to control our servo. We created a couple integers. One is an integer called pot pin. Pot is short for potentiometer. That just means something that has potential, but it varies. That input is going to be coming from A0 or pin 0. That's an analog pin. We have another integer value called val, and that's what we're going to be sending to our servo to set it at a particular position. We have a setup routine that will let the servo know that its control is to go out pin 9. So it attaches to pin 9. And then our loop. So at the beginning, each time, analog read the value from pin 0, or pot pin, and it'll convert that value within this range and send that value to servo. And then wait 15 seconds and try it again. Let's upload this and see what this does to our servo. Well, my servo started to move, and as I move my hand over it, my servo turns about 80 degrees. I suppose the more or less light, or the more appropriate range between that other resistor and my photoresistor would change how this works. Let's see if I can let you see this. I'll put the servo on the table and hook it up. Okay, there's my servo on my breadboard, and as I put my hand over the light to change the resistance, it moves. It's almost as if it's moving out of the way. We know that that's not the case. It's just reacting to the fact that I'm changing the light. It is a little bit jittery, and I suppose that's because the lights in my room are flickering. The darker I get it, the farther it wants to go, to the point where it turns over. Well, let's go back to our code and see if we can fix it up a little bit so it better matches the actual experiment that we're doing. Once this project is done, you should be able to change some of the numbers and values and see if you can customize your code. Well, after you save it, of course. Okay, let's change this program a little bit to make it match what our actual circuit is. We'll just change this variable here. We're just going to rename this to be, let's call this PhotoRes. That just means that down here we have to also change this value to be PhotoRes. There we are. I think that takes care of those values. And then anything up here needs to be changed to match by using a photoresistor. And I'm going to add one more line of code. And I've put the fact that it was modified by me. Okay, let's save this, and as always we're going to save it with a new name, because since we've made a change to original code, I'll click Save As, and instead of knob I'll put it PhotoRes-Servo. Okay, I think that concludes this exercise of using a photoresistor who changes a voltage value that would set the position for a servo.